Good morning. Let's deal with our latest exam paper, February 2022. So I'm taking the first principles example as a revision lesson. So let's have a look. We've got question 2.1. Determine dy over dx if f of x is equal to cos x. Using first principles, we know the answer, the derivative of cos is minus sine. That's using our table of derivatives, but now we need to we need to use first principles, show all intermediate steps, and you're given 2 hints here. Okay, so now your hints. Now this exam paper, there was an error in this part here. The limit was written as x approaches 0, so that was an error, so I changed it. It's the hint, it's supposed to be as h approaches 0 there, and as h approaches 0. Right, those were the hints. That's towards the ending. That's like the second last step of your final answer. You'll only be using, that's a part you'll be using the hint. Okay, so now, let's have a look at how we're going to deal with this. We know from first principles from grade 12, your first derivative so we can say f prime x is equal to the limits as h approaches 0, f of x plus h minus f of x, all divided by h. Basically the change in y, all divided by the change in x as the change in x approaches 0. Right, so now, how are we going to answer this question? How do we use first principles for cos? So let's do it step by step. The given information here, first of all, we got f of x is equal to cos x. This is the formula that we need to substitute into. So we know that where we see f of x, we will replace it with cos. Okay, so now we need a substitution also for f of x plus h, which is the numerator of the formula. Can you see that? Right, so now, all I will do now in the next step is replace. I'm going to replace x with x plus h. So now, if I do it on the left, I do it on the right. This is based on f of x is equal to cos x. So now f of x plus h will equal to cos of x plus h. Now, the next step is to subtract. Okay, so it's f of x plus h minus f of x. So I got my f of x plus h minus f of x. Okay, so my f of x plus h is cos of x plus h. That's what we have here. Here's my f of x plus h, which is cos of x plus h minus f of x. Yeah, I've got minus f of x, which is just cos of x. Now, if we take this information and substitute it directly at the stage here, let's see what happens. Okay. So therefore, my f prime x is equal to the limit as h tends to 0. My numerator, f of x plus h minus f of x, is this whole part here that we just worked out, which is cos of x plus h minus cos x all divided by h. All divided by h. Now you know from your experience dealing with limits with first principles, from grade 12. Then after you do a substitution and simplify, you take out h as a common factor, and then h and h always cancels. We got a problem now. We can't do that yet. There's no common factor. Can you see that? There is no common factor to take out there. So h and h will not cancel. We need to simplify further. What can we do here? We got cos of x plus h. Now, you go to your formula sheet and expand. So now, you go to your formula sheet here. So let me just write that down. And you're looking for cos. You got A, you got B, and how is it given to you on the formula sheet? It's given to you as two formulas written in one. Okay, you got cos of A plus or minus B. So this is equal to, you have a cos A, cos B, you have a sine A, sine B. But what happens here? There's normally confusion with using this formula. There should not be any confusion. Now, if it's a positive, if you are starting with a positive, that means A plus B, then the sign here will be a negative. So, the signs change for the cos formula. Then, if you started with a negative, then the sign will be positive when you expand it. Notice that how I wrote it, if it's, notice the position. Forget about whether it's positive or negative. Notice the position of the sign. This is written on the top. This sign here is in the bottom. So if you copy down a sign on the top, on the left hand side, that means you need to stick to the sign on the top, on the right hand side. Okay, so that means if this is a plus, this must be a minus. If this is a minus, you check this is a plus. You follow the position. Bottom left, bottom right, top left, top right. That's how we use this formula. So what are we using here? We only want A plus B because that's a plus sign. Okay, we want A plus B. So I have cos of A plus B, which is equal to cos A, cos B, minus sine A, sine B. Okay, so now let's apply the formula here. So let me just, this is your formula sheet. So you go to the formula sheet, or you know the formula. It's best to know the formula. These ones you use it all the time. So now, so therefore, f prime x is equal to the limits as h approaches 0. So I'm going to expand now, cos of x plus h. So here, x is a and h is b then. You're clear with that? So now that's going to be cos A, cos B. So that's going to be cos x, cos h, minus sine A, sine B, minus sine x, sine h. Okay, so what just happened there is that we have expanded cos of A, x plus h, which is cos x, cos h, minus sine x, sine h. Don't forget that there's also a minus cos there, part of the numerator. So, don't forget there's a minus cos of x on the top. Now, this whole numerator is divided by h. Okay, what can we do now? Can we cancel? Will h cancel with h? The answer is no, it cannot cancel. This is not h, this is cos of h. Plus, there's no common factor here. So what do? We need to simplify even further. Now let's see, what can we do here? I noticed that there's a cos x here. There's also a cos x there. So let's group them. Let's group these two. Take out a common factor. So this is equal to the limits as h approaches 0. So if I write these two terms next to each other, this term I'll write it at the end, and I want to take out a common factor from the first two terms. So my common factor here is going to be cos x. Okay. This is not common. I'm writing it down here. Minus sine x times sine h. That is not common. So I took out cos x as a common factor. So I'm left with cos h minus 1. You're clear with that? Alright, now this whole thing here is divided by h. But h still does not cancel. It still does not cancel even though I took out a common factor. Now what I need to do now is simplify even further. Okay, so what do I mean by that now? Simplify a bit further. I just need to give you a quick lesson here. 1 minute lesson on limits. So we have if we have the limits, let's say as x approaches 1 of, let's say x squared plus 2x. Okay, let's take this example. We need to just do this before we move any further here. So this is a parabola, you know it's continuous. When x is equal to 1, there's no indeterminate form. This is a determinate function. So if I substitute when x is equal to 1, 1 squared is 1, and then I got 2 times 1 which is 2. So 1 plus 2 will equal to 3. You're clear with that? Now, let's redo this example. I have the limits as x approaches 1, I have x squared plus 2x. Alright, same example. What happens if I deal with each term individually? Let's have a look at what will happen there. So this is equal to the limits as x approaches 1 of x squared. So I'm going to deal with this one first, plus the limits as x approaches 1 of 2x. If I have to split them up, the question is, will my answer be different? Let's check. So if I substitute here, 1 squared is 1, plus if I substitute here, the limit as x approaches 1 of 2x, that's going to be 2, and 1 plus 2 is equal to 3. So I can do it in one step, or I can separate them. It's unnecessary for me to separate them because I could have done it in one step. You're clear with that? But now, here the opposite applies. Here I have to separate them because I cannot do this in one step. So let's separate it. Now I'm going to separate this into 2 different problems. Before we move any further, you must understand that if I have, let's say, 2 plus 5 over 6, let's take this fraction. This can be written as 2 over 6 plus 5 over 6. Splitting up a single fraction into 2 fractions. They must have the same denominator. So now watch what's going to happen here. So now this is equal to the limits as h approaches 0. So remember this, I can split it up into 2 fractions then. So I'm going to have cos of x times cos h minus 1 all over h minus the limits as h approaches 0 of sine x times sine h all over h. You're clear what happened there? I have my common denominator of h. I'm not changing the question in any way. You can see that? Now, remember the error in the paper. The error was here. It was given as x approaches 0, which is not true. This is the correct version of the board. It's h approaches 0. This is first principles. Now, we will be using this hint. Okay, even though the hint was an error, but we corrected it. Now, we are substituting for the variable h, not for x, because this is h approaches 0 here, and h approaches 0 there too. So any other variable there is not affected. So therefore, cos of x is not affected by this number. So I'm only substituting here. I can take the cos x, write it neatly in front. So now I got my cos x times the limit as h approaches 0. And then I have cos h minus 1 over h. So that is term 1. Here, sine x is not affected by h. So that's minus sine x times the limit as h approaches 0, and this is sine h over h. Okay, now we go to our hints. I'm sure you're already looking at the hint. I got cos of h minus 1 over h. The limit as h approaches 0. Cos of h minus 1 over h is equal to what? So you don't have to show how it's equal to 0, you just use the information that's given to you. So therefore, I got cos of x multiplied by 0. That's the given information. Minus sine x times, what is sine h over h? The limit as h approaches 0, sine of h over h is equal to 1. Now, we showed, show all intermediate steps. We are showing everything here. So now, 0 times cos, 0 times anything will be 0. Minus sine times 1 is minus sine x. So 0 minus sine is minus sine x. And is that correct? Yes, because we know from our table of derivatives that dy over dx of cos is equal to minus sine. And that was our first principles. Now, for those of you who were wondering how cos h minus 1 over h is equal to 0, how is sine h over h equal to 1? So let me just show you that, remember, we have done this rule. You can verify it. So verify this part here, sine h over h. So if I say the limits as h approaches 0 of sine h over h, remember the rule. And so now, if I substitute 0 here, sine of 0 is 0. If I substitute 0 here, I'm getting 0 again. So remember, this is an indeterminate form. So if you remember from what rule, what do we do with that? When we have an indeterminate form, we differentiate the numerator, the derivative of sine h is cos h, differentiate the denominator, derivative of h is 1. So what did I do? I found f prime on the top, g prime in the bottom. So now I can substitute my 0 and then I get cos of 0 over 1, which is just 1 over 1, which is 1. So just to verify what we have done. Right, so that was our first principles example.